in there. Okay, so pretty easy day today. December 3rd. Feels like winter's coming finally today. So our objective is really to find the exact values from the unit circle of the cofunctions. Okay, and I'll step back and let you write that, okay? Find the exact values from the unit circle of the cofunctions, okay? Find the exact values from the unit circle from cofunctions, okay? So our cofunctions are really going to be cosecant, secant, and cotangent. Now, I didn't make this up, because you would think cosecant goes with cosine, wouldn't you? Wouldn't you think cosecant goes with cosine? No, it doesn't. And secant, no, that doesn't go sine. It goes with cosine, right? So this is the same as 1 over the sine value. This is 1 over the cosine value. This is 1 over the tangent value, which of course makes its reciprocal, right? So instead of y over r, it's r of y. Instead of x over r, it's r over x. And instead of y over x, it's x over y. So we're just going to use that information and use our unit circle. So here's what you need. Cosecant. Now since we're on the unit circle, r is equal to 1, right? I'm going to highlight that because that's going to help me, okay? So it makes it easier. Know what the radius is. Radius is 1. All right? So cosecant is r of y, or it's the 1 over the y value. And I'm going to go to 30 degrees. And 30 degrees, the y value is 1/2. So I'm going to have a 1 over a 1/2. That's a bad looking answer, but I can flip this up, and the answer is 2, or 2 over 1. Okay, with me? I just flipped it up, right? Secant is r over x, but the radius is 1, so it's really 1 over the x value, right? 315 is here. 1 over the x value. And my x value is square root of 2 over 2. So I'm going to have a 1 over the square root of 2 over 2. Now that's kind of a mess. Let's see if I can fix that, okay? So that's going to be 2 over the square root of 2. If I flip it, I'm just flipping these fractions. That's all I'm doing is flipping these fractions. But that's not a very good answer, so how are we going to fix this answer? Yeah, rationalize the denominator. Ooh, that was so well said. Square root of 2, square root of 2. Thanks, Lauren. So I'm going to get 2 square roots of 2 over the square root of 4, which is 2. Let's cancel the 2's, and there's my exact answer. Did I go too fast on that? Okay, I'll show it again, because there's a lot of little tricks in here. So first of all, 1 over the x value. 1 over any fraction flips the fraction, so flip the fraction. Lauren said you got to rationalize the denominator, so multiply by square root of 2 square root of 2. Remember, fixed problem. You get 2 square root of 2 over the square root of 4. The square root of 4 is 2. I cancel the 2's, okay? All right. Now, cotangent. So cotangent is going to be my x over my y. I'm going to go 240. 240 is here, and it's the x over the y, so it's a negative 1/2 over a negative square root of 3 over 2. And luckily, we kind of did the work on this on the board already, so which is going to help. Negatives cancel, the 2's cancel. So I'm left with a 1 over the square root of 3, and when we rationalize that one, right, we'll get 1 square root of 3
over the square root of 9, which is 3. How am I doing? Juan, am I doing okay? Are you going too fast? I'm okay? All right. Cosecant, a negative 60 degrees. If 60 degrees is a rotation this far, then let's just rotate the tire backwards the same amount, which puts a negative 60 degrees here at 300. And I'm doing my cosecant there, so I'm doing 1 over the y value. So the y value is square root of 3 over 2. So I'm going to have a 1 over a negative square root of 3 over 2, right? Okay, same thing. Can have 1 over a fraction, so I flip it, get the reciprocal. So I'm really going to rewrite this as 2 over a negative square root of 3. Have to fix it, right? So multiply by the square root of 3, square root of 3, and I'm going to get 2 square root of 3 over a negative 3. Okay, I'll show this one again. This one again. Okay. I found negative 60 degrees. The y value was negative square root of 2. I flipped it, right? Can't have that answer, so I got to fix it. You look so tired. Sorry. Bracket, so I multiply square root of 3 over square root of 3 gives me 2 square root of 3 over square root of 9. You guys see square root of 9, which is 3. Okay, thumbs up. Hang in there, man. Hang in there. You get to sleep in tomorrow? You have to work tomorrow? Yeah. I'm sorry. Okay, I'm squishing in. Secant of 400. This should have been 420. Dang, I got to go back and fix those. 420. I keep putting the wrong number down, which is really 360 plus 60, right? So I'm going to go to 60 degrees, which is there. Secant's 1 over the x, which is 1 over 1/2. Oh, this is an easy one to do. 1 over 1/2 flips up to 2. Good. There was no fancy work. I like that one, okay? Cotangent, 180. Okay, cotangent is the x over the y. Let's go to 180. There it is. X over the y. Ooh, this is going to be bad. Negative 1 over 0. What's that going to be? It's going to be a sad cookie monster, isn't it? Undefined. Cool. Okay, number, example 2, same thing except it's just in radians, okay? So, I'll try and put it over here because I kept squishing them. Cosecant's the y, 1 over y, 3 pi fourths, right there. The y value, square root of 2 over 2. So it's 1 over the square root of 2 over 2. And I think I did that work already here somewhere, right? I think I did that exact work. I did it right there, didn't I? So that flips up and rationalizes. So let's just skip the work since we've already done it. Square root of 2, right? No reason to do it again. Okay, secant. 1 over the x. 5 pi 6. 5 pi 6 is here. The x is negative square root of 3 over 2. So we go 1 over negative square root of 3 over 2. And I think I've done that work too, haven't I? You see that one somewhere? Yeah, right there. So I've already done this one as well. I did all that work already there, so I already have that answer. We flipped it, we rationalized it. It just turned out to be 2 square root of 3 over negative 3, okay? Yeah, why do the work again when we've already done it? You guys agree with that? Am I going too fast? Okay. Okay, cotangent, which is going to be our x over our y. So, cotangent 2 pi thirds is there. The x over the y. So we're going to go negative 1/2 over square root of 3 over 2. And I think I've done that work somewhere also. Haven't I done that work already? think that was right up there. It's right there, right? Except for my answer is going to be negative. See, I've done all the work there, so I did this work right there, except for the fact it's just going to be a negative, right? So I'm going to have a negative square root of 3 over 3. I mean, you guys are okay. I don't need to do the work again. Agree? Cosecant of pi. Well, cosecant's 1 over the y value. I go to pi. The y value is 0. Uh-oh, we're going to have a problem. 1 over 0. Cookie Monster sad. Undefined, right? Am I doing okay? You guys with me? You understand? Seem easy? Okay, good. Secant is 0. Secant is 1 over the x value. And 0 is 0 right there. 0 radians, 0 degrees, whatever. Secant's 1 over the x value is 1. That's easy. I got 1 over 1, which is just 1. Okay. Okay, cotangent is the x over the y, negative pi 6. Well, if pi 6 is a rotation to here, let's spin the tire backwards and go to here. And we're looking for a cotangent, which is going to be the x over the y. So it's going to be a square root of 3 over 2 over a 1/2. Oh, there's a negative in there somewhere. Yeah, it's the y value, negative 1/2. The 2's cancel, right? You guys remember how the 2's cancel? So I'm really left with this negative square root of 3. Okay. Okay, turn the page. Okay, now, the calculator. It might seem really easy, but it's not as easy as it appears, okay? So, grab a calculator. And again, the reason it's not as easy as it seems is because there is no secant button on my calculator, is there? You guys agree with that? But there is a 1 over cosine. Okay, and I'll wait for you to look at that, okay? So there's no secant button, but we don't need a secant button. It's just 1 over cosine, right? Now, obviously, we're going to have to check our mode, right? Better check our mode. So I'm going to go to mode first. I'm going to put myself into degree mode, right? And then I'm just going to type in 1 divided by cosine 58. That's my answer. .887. Thumbs up? Okay, now, B. First of all, let's change our mode. You guys agree? It's got to be in radians. Okay, mode. Oh, calculator's dead. Grab the other one. Got to charge this in. See? You ready, Ethan? Here, I get the vent. Take the vent. Why is my calculator dead? Because that thing's always unplugged so kids can charge their phones. Okay, anyway. Let's try this one because it's battery. Okay, so I'm going to go first mode, right? I'm going to go to radians. And there is no cotangent button, but we have a tangent. It's 1 over tangent of 1.2. Okay, so then quit. I'm going to go 1 divided by tangent of 0.2, and I get an answer of about 0.3888. I like to go the nearest thousandths, so 0.3889. Actually, round to 9, 0.3889. There we go. Now the reference angle, okay? I've talked about the reference angle before, but a lot of times kids don't get it the first time. So the reference angle, we got to think about a right triangle. So when you think about the reference angles, we've got to think about a right triangle because the sine, cotangent, sine, and the tangent, all of those are created by right triangle, right? So we have to create a right triangle in here. And what we've seen from the unit circle is that the answers are very similar no matter what quadrant you're in because they're all the same triangles, right? These triangles are all the way around here. So a reference angle just gives us the same angle but just different signs. Okay, so, all right. I'm going to draw a picture. And I've got my 130 degrees here. So this angle is 130 degrees, which makes this angle here 50 degrees, okay? So you always want the right triangle and Kai asked this. You always want the right triangle on the x-axis. And the reason it's on the x-axis is when we graph points over and up, right? So my reference angle is 50 degrees. So I know this. Here's why the reference angle is important. Okay? The sine of this angle is also the same as the sine of this angle. So the sine of 130 degrees is equal to the sine of 50. Because it's the y, right? The cosine of this angle is just the negative of this angle. So if you use your calculator to do cosine of 50, cosine of 130 would be just the negative of that answer. Does that make sense? The tangent of 50 would give you some value. And the tangent of 130 would just be the negative of that. Does that make sense? And that's why the reference angles are so important, okay? Cool. All right, last but not least, let's do this last problem, okay? Let's see what it says. In fact, we kind of did this one in our warm-up, I think. Kind of did. Okay, example 5. If theta is in quadrant 2 and tangent is equal to negative 3/4, find the other 5 trig ratios. Now, this is on your test. It's actually really easy. I'll show you how. First of all, quadrant 2, right? I'm going to draw a reference angle. Okay? I know that tangent of any angle is the y value over the x value, okay? So that means, in a sense, I've got a negative 3/4, or I've got a 3 over a negative 4. Now I want to emphasize this one. Same number. These two are the same number. You guys agree? You guys agree with these same number? The reason I changed it is because to get to quadrant 2, I have to go back and up. Do you agree with that? If I kept it this way, I'd be in quadrant 4. Make sense? So now it's easy. I know my x value is negative 4, my y value is positive 3, and my radius is square root of negative 4 squared plus 3 squared. There's my Pythagorean theorem, right? Which is 5. 3, 4, 5 triangle. You guys all know about the 3, 4, 5 right triangle. So R is 5. Okay, now it's just like our warm-up. And I'll wait till you get caught up. Sine is the y over the r. Cosine is the x over the r. Tangent is the y over the x. My cosecant is my r over my y. My secant is my r over my x. My cotangent is my x over my y. So I'm just going to put the numbers in when you guys are caught up, okay? We use these numbers, right? These values. And so, sine of theta, 3 over 5. Because it's the y over the r. Cosecant is negative 4 over 5. Tangent is 3 over negative 4. We kind of knew that one though, didn't we? Cosecant, just flip these. Make it easy. Don't even bother, just flip these. They're just the reciprocals. 5 over 3. 5 over, what is it? 5 over negative 4 and negative 4 over negative 3. Okay. Oh no, that's a positive 3, my bad. How's that? Pretty easy? Lauren, did I make any mistakes? I didn't make any mistakes? I don't think so. Okay, so here's our homework. We had lots of time to work on it. Awesome. I mean, we got a half hour just to chill. Let's get it done. I like the unit